about the inputs, outputs, processing functions, and the hardware requirements. And then in the processing function, what kind of domain functions we need. The domain functions, what is a 1D transform, we checked it. So in the 1D transform, Hadamard transform, we followed it. So if you check the Hadamard transform functions, this is the direct functionality. That means only a forward path is there. Okay. So if you check the entire flow, everything is a forward path. There will not be any feedback path. So if I give an input here, set of input here, it will directly process, it will go to the next stage, it will process, it will go to the next stage, and till last it will end. Okay. So here I didn't record any control logic, something like control pins. So whatever the data pins are there, this data pin itself will act as some enable or disable pins, something like a select lines. Okay. So other than that, other than the input data, we didn't give any other extra data for this circuit. So this is completely a parallel circuit and independent circuit. In case if you are providing some other control pins over this, then this control pins will decide the performance of the function. So here, if I give the input, definitely I'll get the output. But if you have the control pins extra, if you give the input, based on the control lines, it will decide whether it has to read the input or not, or whether it has to process the input or not. So based on that, the performance will get changed. So next, we'll check how we can able to build a 2D transform using a 1D. Something like, first we need to understand what is a 2D and 1D. Before going to that, we have some small doubts. If I have a 1D 64-bit, 1D 64-point transform and a 2D of 8x8 transform, is that one and the same or different? A 1D of 64-point transform function and a 2D of 8x8 function, transform function, is these two are one and the same or these two are different? Same only. Of course, you will get the same result. It's nothing, it's not 1D, it's not 2D. Actually, for that 64 point, what is the transform domain, the other domain coefficients, what is the coefficients I have to get? That is the only meaning. So, if you are finding a 1D transform of 64 point or a 2D transform of 8x8 point, okay, both are same. Why in the sense, initially I am going to calculate all 64 point as an input, I will process as once. So in the one flow, I will try to process all 64 as a single set. But to process that, just think about the previous 64 2's complement circuit you need. Here 2 into 64, 128 muxes are needed, and each will not have only one bit, it's an n bit. Okay? And again 64 sign reduction tree it's needed. Again CLA 64, again 2's complement circuit. This negation of sum plus 1 is nothing but 1's complement plus 1, which is again 2's complement circuit only. Again here 2's complement circuit, again mux. Okay? So even though this is optimized for the higher order transform, this will not be the better solution. So the hardware requirements will still more. So what we can do in the sense, we can find out the 2D using the smaller point, FFT. So how in the sense, we have the 64 points as a single row. What I'll do, first 8 pixel I'll keep, second 8 I'll keep it to the second row, third 8, third row, fourth 8, fourth row, like that. I'll keep on. Like that, when I keep on move all the values as 8, 8, 8, I'll get 8 rows. After these 8 rows, each row will have a 1D of 8 point, 1D transform. Is it correct? So each row will have only 8 points. So this will have 1D 8 point transform function. So like that, I'll first process the 1D transform of 8 functions. But to process this, just think it, what is the method I have to follow? Look on the formula, this is a common formula for all the functions. Actually, instead of the W, if you keep with respect to the transformation function, whatever the e par or 1, whichever is there, if you replace, the respective transformation function will go. This is actually the normal transformation function for the 2D. Okay, so I have X matrix, I have that means M matrix and L matrix, two things. So with this, I can able to represent the entire 128 element or 64 element, whichever I have. So I need to separate this function into two different 1D functions. So I need to separate the summation function first of all. So to separate it, I'll just change this L and M as X into 8L, because it's 0 to 7, total 8 elements, 8L plus M into this function Ws power Ls and Mr and Ms. If you multiply and keep this, you will get it this. So after getting this, again just check it. In case if my M is fixed, L is varying, that is the first thing. So if my M is fixed for 0, the first pixel value is 8 into 0 is 0. The second value is 8 into 1 plus 0, which is 8. So the second sample value is not the first sample, it will be the 8th sample. So it meaning initially I got the sample as 0, 1, 2, 3 till 63. This is the sample I got. When I convert my 1D sample into a 2D, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on, 56 to 63. So this is the thing I will get. So once we get this first row will go for one transformation. That's what 0, 8, you substitute 2 here, 8 into 2, 16 plus 0, 16. So third sample is 16. But in real time, when we want to process the signal will come 0th sample, first sample, 8th sample will not come until 7th sample are reached. Okay, so I can't able to process. This is a one more drawback whenever you are converting a 1D value into a 2D. This is one more drawback. So you can't process the samples in order. So if you want to process the samples, the sample order will be with some different positions, 0, 8, 16, something like that. Okay, so again in this, if you want to process as butterfly, okay, so in the butterfly when we process, we can able to say this is actually x of 0, this is x of 2. Okay, so again this is x of 0, this is x of 8. Okay, so again when you keep on move, it will be different. So when you process for the 16 point, the 0th sample and the middle sample, that means end point, the 0th sample has to process with the midpoint, n by 2 point. Okay, so first sample mid plus 1. So like that it will keep on move. So if I want to process like that, again the sample reading is in random order. So this is another drawback. So in case if you want to do any framing kind of thing, whenever if you want to process any signal, we need to do a windowing and framing initially. So the windowing and framing may have overlap with the framing window. So if it has an overlap, again these samples will get repeated, the third drawback will happen. So we need to overcome all these things, and we have to process the input signals in real time, means with the same clock rate again. So what we can do in the sense, we can process the entire image or entire functionality with the sub-functionality. That means we can divide into smaller images. So sometimes you may not require the entire image processing. Something like for a watermarking, I don't require the complete information behind the image. But for the edge detection or some object detection, you need the complete information behind the image. So what kind of object it has, where it took, and where are the edges, all these things you have to take it out. So in this case, the entire image transformation is required. But for watermarking kind of thing, the entire image transformation is not required. Maybe I can consider some 64 pixels or some 8 pixel alone as a single image. So continuous 8 pixel, I'll consider as a single sub-image. So this sub-image alone, I'll do the transformation function. I can process, I can do whatever I want, I can inverse transform. So this will give the same performance as like the previous thing. But the only thing we can able to achieve much better performance compared to the previous, that means the conventional of entire image. The reason the processing overhead we are reducing instead of 64 as 8. Okay. So what I did, 8 is a very small number. Anyone can able to easily find out. So it should be somewhat optimal. 64 is a nominal number. So we grouped the entire image into 64 pixels of subframes or sub images. So entire image will be divided into 64, 64, 64 sub images, continuous pixels of 64. Again this 64 we need to convert into 2D. So once we convert into 2D, the structure will be like this, the input matrix structure. So first zeroth sample, first sample, second sample, third sample till 7, like that 63 samples will be there. But if I want to do the transformation function for this subframes, actually I need to do first this 8 set of values. So which is nothing but 0, 8, 16, 24, 32, 48, 56. So this 8 set of values I need to do. So in this 8 set of values, butterfly required 0 and 32 sample. So for the first butterfly, as per your formula, it required 0th sample and actual 32nd sample. Yeah, here. Okay. So we divided into, for understanding I divided into 2 separate groups, and the second 8th sample require 40th sample for the second butterfly. So third 16th sample require 48.